Hello and welcome, everyone. We're really excited to have you all here today for our weekly deep dive series with OCI Product Management. My name is Kenna Ketrick. I'm a program manager with the OCI go-to-market team. And today I'm joined by Sebastian, consulting member of technical staff with the Maximum Availability Architecture Product Management team. Sebastian will highlight the automated benefits of Oracle Maximum Availability Architecture with a focus on new high availability, scalability, and disaster recovery features. As usual, before we get started too far into it, I do have a couple polls. So I'm going to launch our first one here. We design our weekly sessions with you, our users, in mind. We put you in touch with product managers behind our recently launched services. So if you would give us a moment, share what interests you most, that will help us shape our future upcoming sessions. Speaking of future upcoming sessions, we do have one event next week on Thursday, April 29th. We have an update on how OCI block volume, object storage, and file storage services are changing to improve performance, reduce costs, and improve disaster recovery. And you'll get a demo of some new capabilities and a little sneak peek to see what's coming next. So I'll drop a link to that in the chat as well so that you can see what's coming up next week. There you go. All right. Thank you. And then I'm also going to drop a link in the chat to a survey that we run with OCI customers. Your opinions are very important to us. We really appreciate if you have 1 to 2 minutes of your time a little bit later, provide us with your feedback about your experience. We always appreciate that as well. And then our second poll, we're starting up limited availability access program for new OCI services, and we want to extend an invite to our customers and our partners. So if you're interested in participating in early previews, go ahead and select yes in this poll screen, and we will follow up with further details for that. As a reminder, as we get going, for today's session, we encourage you to use the Q&A window at the bottom of your screen for any questions for the presenters during the presentation. And we're also going to record this session. So if your colleagues were unable to make it, we'll be posting the replay, and I'll drop links in the chat a little later for that as well. All right, that is all from me. And I'm going to go ahead, hand it over to Sebastian. Take it away.
Hi, everyone. So welcome to the session. So as Kenna said, you probably were expecting OCI product managers, and now you have to do with a consulting member of technical staff. The reason for this, I have been working for the Oracle database for about 20 years now, doing anything which had to do with high availability. And I did join the OCI team when it essentially was growing and building up the database cloud service, always on a very technical upfront. And I was responsible there essentially to bridge the gap between new cloud architecture and the Oracle database, explaining to the database team what cloud is all about, and on the other side explaining to Oracle Cloud people what essentially an Oracle database can do and how it's providing high availability. And one of the things I do want to cover today is essentially how we do ensure to reach our goal, because I mean, we are Oracle and we know how to run databases, so therefore we also want to ensure that whatever best practices exist to run an Oracle database and to make it highly available, that you do get this capability also in the cloud. So the goal definitely is to essentially bridge the gap from a single instance up to the highest availability without any downtime for patching and upgrading. Are we already at 99.999%? No, unfortunately, we are not, but we are getting really close to this goal. And we are also undermining that on some cloud services, which SLAs, which we do give out, not for the 5 nines, but a little bit less as of today, but essentially to provide you with the same capabilities. And if you do add a little bit of manual work to your database cloud service, you can get pretty close to the full 9s, but that unfortunately still requires a little bit of work. So essentially, as Kenna already pointed out, I'm working nowadays for the MAA team. And so therefore, I do work with all technologies which have to do with MAA and try to bring them into OCI, starting with simple backup and recovery, going over real application cluster and also explaining a few things in this webcast to you, what capabilities we essentially get on scalability with real application cluster, up to setup of disaster recovery site with the help of DataGuard, which essentially is our gold level, and up to the platinum with full availability, so to speak, but that also requires Golden Gate. And there was just a recent announcement that now OCI Golden Gate, so the cloud service for Golden Gate, has been launched. But that is not part of the session today. But you might want to look at it if you really want to reach the platinum level. So what is essentially provided in these levels of the MAA architecture? So in the minimum, and that's the minimum which we have to provide for the database cloud service, is definitely backup and restore. So in single instance databases, which is most sufficient for running TAF, DEST, and even a few production environments which probably don't have these high requirements of RPO and RTO, so recovery time and recovery point objective. Backup and restore might be sufficient. It's still important to know how this is operating. We will look at this a little bit on what the Oracle Database Cloud Service provide out of the box there. Then the next level, which is silver, which adds to the whole stack the real application cluster to provide HA, so that even if one of the database nodes for whatever reason goes down, or for example, in VMDB case, when you have to do scaling, that you can scale online, even though we have to take down one of the RAG nodes to do the reshaping, which I will explain a little bit later why. That you still are online and essentially can do the scaling in one go with help of real application cluster, up to the business critical level, which adds DataGuard cross region or within the availability domains, up to platinum, which essentially adds features like Golden Gate and edition-based redefinition to the whole MAA stack. So that is our goal. And what we will be covering today is essentially what can be achieved. One thing I do want to highlight and always want to point out, because that hasn't changed in the cloud to what customers are running on-premise and is a crucial part to essentially reach the high availability for applications, are two features which are often not really investigated too much by customers, but they were already there with the Oracle database, and they're also there in OCI. And one of the things is for planned downtime, which is called fast application notification. So the capability of the Oracle database to inform the clients if anything has happened on the database side. So for example, if you do have done a switch over in DataGuard environments, to essentially inform the connection pools of your applications that now they should better connect to the standby than to the primary because you just switched over, or in HA cases on a real application cluster, that if you do follow the Oracle best practices to do rolling patching, so one node after the other, or the capability of scaling when you have to do when you have to take down a node to do scaling, that essentially the application does only connect to the node which is still online until the node is back up again. Then FAN, or fast application notification, is really, really important. And the other point to it for unplanned downtime, so hopefully we will never have one in OCI, but they still might be existing. So for unplanned maintenance or downtime, we do have a feature which is called application continuity, which was really enhanced in 19C. So there's also another name with 19C called transparent application continuity, to essentially highlight that most applications can make use of that feature today, even if they are not using the Oracle own drivers where this was implemented before. And definitely a thing to look at. So there's a good white paper on that. And that is one of the key developments to provide MAA overall, even though if you have set up everything, and if you're using a real application cluster in OCI or using autonomous in OCI, which provides a real application cluster under the covers for you, that you essentially get all the capabilities on the client side. So coming to the agenda, before we come to the agenda, let's have a brief look at what we have and how you can provision databases. And we actually have another poll here because I just would be interested in how do you run data, if you do run databases at all, how do you run them in OCI, which database cloud services you are using today. So just to know, yeah, how can you deploy databases at all? First of all, yeah, you can use OCI like just an infrastructure cloud provider and just use an IaaS shape essentially to run your databases, which does provide you with a few capabilities. It also allows you to take the latest and greatest AMD shapes, which provide flexible scaling to this. Then up to what we call co-managed services, like VM database, providing you with all the types of editions, up to a real application cluster. Then we do also provide you with bare metal shape, which has really, really good performance. However, just to being said, at this point in time, the development are mainly done for VMDB database service and especially Exadata. And Exadata, I mean, there's sometimes the question, why don't we provide a bare metal real application cluster? Your bare metal real application cluster in OCI is actually Exadata Cloud Service, which uses dedicated local storage. So you do save on the block storage costs by using XSCS, and looking at the capabilities with online scaling, which we will briefly look in the scaling part, you will see that it does provide a lot of value without having any drawback, and is essentially the solution if you want to run a bare metal rack, so to speak. Up to autonomous, with autonomous free or autonomous shared or dedicated, which I will not be targeting too much in this webcast, and I'm concentrating essentially more on VM case. So, 2 examples in the cloud. Autonomous shared, because I just thought, okay, let's take the two more easier services to deploy before we go into the deep ones like XSCS. So I took 2 examples, and I want to look at what do we provide out of the box in case of backup and recovery. What do we provide out of the box for disaster recovery, so setting up data guard. And how does this look like in contrast to this when you do decide to run it on a VMDB system? What do you get there, and why do you only get real application cluster with this? Then we will look a little bit on the scalability side. So what kind of scalability is provided to my database cloud services? And last but not least, depending on time, we will also look a little bit at the hybrid cloud use cases. So what do you get and what to expect if you are still running your databases on premise, how you can easily exploit the Oracle Cloud capabilities to just store your backup, for example, what is done by that, what maybe you have to look at, and essentially also how to set up a hybrid data account. So let's start with what do you get out of the box on autonomous database shared in regards to the MAA architecture, so what we do provide there. And autonomous database from day one was always built in mind with the MAA architecture. So Oracle itself does totally take care of the backup, nothing you need to worry about. We also do automatically take backups from the primary and the standby, which we will be looking at a little bit later in the data guard implementation. The autonomous shared database is running on the best hardware for an Oracle database you can get today. So it runs on Exadata under the cover, which does provide you the performance benefits with all capabilities an Oracle database has. And additionally, you do have the capabilities to set up what we call autonomous data guard on the database level, on the autonomous database level, to essentially allow you to run as of today only within a region with the disaster recovery side. We are working on cross-regional data guard, autonomous data guard, to be providing you with this feature also across regions. There are some things simply to know about the data guard implementation and the backup and recovery. So let's start with what do we do for automatic backup in case of autonomous. And yes, you cannot influence that in any way because it's Oracle responsibility to provide you a high availability service. But it is sometimes nice to look a little bit under the cover. How do we actually do this? So as I said before, it's automatically done by the service. And how this is essentially done, it's a little bit different to what we do on XCS or on DBCS. We only take a full backup every 60 days, daily incremental, and hourly archive log is, well, it's actually 30 minutes archive log, so there's a typo in there. I have to correct this. It goes to an internal bucket, no direct customer access. It's a three-way mirrored backup because the backup goes to the object storage as of today. Backup replication is available with Autonomous Data Guard. So if you do want to have two sites, then backups, then you can use Autonomous Data Guard for this. On the other side, as I said before, it's Oracle responsibility to restore your database. So nothing you have to worry about. The credentials to store the backup is automatically managed by Oracle internal. Also nothing you need to worry about. You can choose essentially to use the TDE wallet, which is managed and used by Oracle. We are also working on KMS or OCI Vault integration, which is an immediate roadmap item, but unfortunately not available yet. So in-place restore only. This is quite important to know. So you cannot use the backup of Autonomous today to restore it to another site. If you want to do that, you essentially would be using another capability, which is called cloning. And we also do support cloning from backup. However, your primary database is essentially there for you to be able to clone. So the restore is only used if something is failing, and then, as I said before, that everything is available is in the hands of Oracle in the case of an autonomous service. Most important part, and that might be the biggest difference to how DBCS is run. So for the automatic backups, which we do today, you are not get charged. So that is part of the service offering in Autonomous, that whatever backups are done is essentially taken by us, and it's covered by us because it's our responsibility to run your service. A few things important to know when you're working with Autonomous Shared, it's in the documentation, but sometimes easily overlooked. So your backup retention is always 60 days. You can't configure that. Essentially, it means that you can do a point-in-time restore back to 60 days. However, these backups, unlike the DBCS backups, are only available as long as the Autonomous Database instance is available. If you decide to terminate your Autonomous Database instance and then suddenly recognize a few days later, oh, that was probably not the best way, you want that Autonomous Database back, there is a way to do this, but unfortunately only via service request. So you might not really want to terminate your Autonomous Database if you still need it. And you unfortunately can't also use automatic or manual backup for this because the manual backup as of today is also tied to the backup retention. So the manual backup, which is provided by Autonomous, is really only used for fast point-in-time recovery. If you need to reset your system to a state where you essentially want to run tests, then this is the best way. By the way, internally, depending on the time frame you are choosing to do a point-in-time restore of your Autonomous database, we will be using flashback under the cover. If we do recognize you don't want to go back more than a week, so we have that flashback, then we will not do a manual point-in-time restore with that. So what about the real application cluster implementation in Autonomous? You do automatically get services, which is one of the key differences also to the DBCS service, which we will see later when we look at the VMDB service, because these services, database services, are not created in DBCS. They are, however, created in Autonomous, high, medium, low, and on Autonomous transaction processing, you also get a TP and a TP urgent, and you can configure these services on how much load and how much parallelism they should have. In standard TP and TP urgent does not have any parallelism. Client access today is only via secure lines, so via SSL or TLS to be more exact. You can configure application continuity, which I mentioned before. And since the whole setup to reach an autonomous shared database is using connection manager in between the connection to the DBCS instance, there is no requirement for you to use FAN events, so fast application notification events, manually. That will essentially be handled by the access layer to the autonomous database for you. And just as a side effect, as long as you run with lower CPU counts, you will the database instance will only be opened on one node. So your pluggable database will only be available on one node. If you do decide to scale up, there is a certain threshold when suddenly it will open up on two nodes. And even though technically autonomous shared is always running on full exadators, on big clusters, your own autonomous database will only be open on maximum with two nodes, up to 128 OCPUs in default. Patching is rolling, will be announced to users. You don't expect any database downtime. The only thing you should know is that, yeah, we will be moving your PDB in your autonomous database to another server, which you might recognize essentially that a long-running transaction might get impacted. So autonomous shared via, if you want to set up data guard via the control plane, it's essentially a one-click thing to do. It's really easy. It's a simple primary standby setup across ADs, across Exadata racks. So we make sure that this is running on another rack as of today. It's not available cross region yet, as I said. The configuration, however, is asynchronous. So you get a recovery point objective of 5 minutes. RTO is up to 2 minutes if you do switch over or fail over through the console if you require that one. So in contrast, let's look at what virtual machines, the other small, so to speak, small brothers, so the other decision which you essentially can do for virtual cloud databases. So some basic information before. DBCS VM itself is using the standard compute shapes, Intel-based compute shapes, which you essentially get from the compute storage. So same thing like you would get if you run on IaaS. We do use block storage, which is triple mirrored. You can choose to either deploy your DBCS system with LVM, with a logical volume manager, which does provide you with the file system underlying the database instance. So that might be quite nice for customers not wanting to use automatic storage management. On the other side, we do recommend from the MAA perspective to use the ASM instance, even though that takes longer to configure. It comes with a full grid infrastructure stack. That is also the only way you can get a real application cluster. Yes, the VMs are automatically restarted on failure. So that is nothing you need to worry about. And internally, I will be covering that a little bit later, but hopefully, because you know Oracle Cloud Infrastructure, you already know there's some construct which is called fault domains. We do essentially ensure that your real application cluster node is launched in different fault domains. So whenever there would be an effect on a single fault domain, your whole real application cluster is not essentially affected by this. So from an MAA perspective, what do you get with the different software editions you can essentially run? Flashback query is available even on standard edition, which is actually a high availability feature. Backend recovery, yes, you get an overall, but unfortunately not in parallel on a standard edition, which might affect the way how fast backups can be done. There are a few things about multi-tenant and refreshable clones, so to speak, single CDB per VMDB system, and single CDB for, even for Enterprise Edition. Yes, you can have multiple PDBs in the CDB, but VMDB systems will always restrict you to a single CDB. What we, by the way, just provided 2 weeks ago is the capability to now clone via block storage cloning all VMDB systems, so even the real application cluster ones. So you can clone RAG to a full RAG. That was just released about 2 weeks ago. RAG, if you have real application cluster, you need the Enterprise Edition Extreme Performance and 2 nodes to this, and which also includes active data guard, part of the MAA architecture, and the capability to set up data guard through control plane. Again, application continuity, which I showed you before, does require an Enterprise Edition Extreme Performance, because that essentially requires real application cluster or active data guard to be used. So if you're looking at the cloud architecture today with a single VMDB node, and the only protection you actually get is the automatic backup, which you can configure. And I do recommend to configure that automatic backup, because one of the things which a lot of customers fall in, we essentially do automatically have enabled the archive logging, because that is key for an Oracle database. And if you do not configure the automatic backup on a DBCS systems, essentially the backups are not done. And since the backups are not done, the archive area will essentially contain more and more archive logs, and they are not eligible for deletion. So that one thing to know, that it's always a good idea to enable backup, or essentially to disable the archive log mode, but that has some implications in general, which I would not recommend. So therefore, better to enable automatic backup. You don't have a capability to run RAG, and yes, you can still set up data guard even for the single instance databases. But from a MAA perspective, that does only give you timings in the minutes for the RPO and for the RTO, or even up to hours, depending on failure scenarios you have. But we still make sure to not lose any data. If you do want to have a little bit more, then yes, you would be running a real application cluster, which provides a lot of the things out of the box, and the whole thing is set up for you, so you don't have to deal with the correct setup. You don't have to deal with creating floating IPs in the virtual cloud network. This is all done for you. And this is one of the reasons we also decided to only provide real application cluster in DBCS instances and not allow the installation on IaaS, because you have to take care of quite a few things to create a real application cluster in the virtual cloud, that everything is working correctly. And that was one of the main decision points, to provide real application cluster only within DBCS VM, and essentially under the umbrella of the co-managed service when you want to have more access. So how does the backup look for a DBCS VM instance? Everything is also done by the control plane. If you do want to configure the automatic backup, which we do recommend, the automatic backup in this case is a weekly full and a daily incremental. Additionally, there's an automatic hourly archive log done by the DBCS agent. So normally the whole scheduling is executed by the control plane. So there's a control plane issues when the backup should be run, and you can control this. However, the archive log backups, the hourly, is done on the box itself by the agent running on the box. The destination, even though it's an internal bucket, which you cannot access directly, so the customer cannot control directly, it does go to the object storage, which is also triple mirrored. And however, in that case, unlike in autonomous, which is the last point, you essentially will be charged for the object storage when you store your backup there. Everything to access that bucket is totally controlled by control plane. We do ensure that we manage the whole backup for you. We do the automatic password rotation, that no one can access this bucket as easily. We do ensure that all which is required to restore your backup is also backed up. So if you, you probably know that DBCS itself is using encryption throughout. So you have TDE configured, transparent data encryption, which does work with the wallet. And we also do take care of the backup for the wallet. What we, however, do not store is the password, which is used to open the TDE wallet. and that you will see when you try to restore a database over the control plane, we essentially will ask you for the TDE wallet. And until a few months ago, we did not provide the option to specify the TDE wallet password separately from the system or sys password. And I had a few customers who essentially launched their DB systems, entered the password for the database there, then forgot the password, didn't mind because they, well, changing the password for the sys user is easy. Just log into the database as sysdba/sysdba and do an alter sys identified by to change the password. What they did, however, not expect was that the same password which was used during the DB system creation is also used for the TDE wallet. And if you do forget that, then you will have problems in the future to access your database. So whatever you do, make sure you do not forget that initial password. Otherwise, restoring a backup might be a little bit of a problem if you forgot that password. No capability to restore across ADs or regions yet via the control plane. There exists a manual way to essentially do the restore and how to get access to the bucket, but it's not quite as easy. Definitely something we need to work on. And the other things which we do not provide today is backup of the standby database, which you are actually used to have on premise. That's another shortcoming we try to solve. So what are the best practices? What is really important to know in case of a DBCS backup is that the backup time depends a lot on the VM shape you have essentially chosen, because the VM shape defines the network bandwidth, which is directly correlated to the CPU. And that even hasn't changed with the flag shapes. If you are using IaaS and use flag shapes, it's the same thing. The CPU defines how much network you essentially get. And since in OCI, the network is dedicated to you and we make sure it's not oversubscribed, so no one will be using the network except you, which provides you with the predictable performance in OCI, that also for IO heavy workloads might have an impact. And the same thing for your RMAN backup. I mean, if you do the RMAN backup to the object storage, yes, we automatically do use compression and we automatically use low per default, though you can switch it to medium or high. It's all included in even the standard edition. You have to know that the network is most likely the limiting factor when doing the backups to the object storage. I always recommend to additionally take a wallet backup manually even though we do back it up, because that is the most crucial point to get access to your data and your backup. If you lose the wallet, then essentially you also lose all the access to your data, because that's how transparent data encryption is working. If you want to monitor the backup, you can use the event service. So just a few tricks and tips around backup here. For DataGuard, yes, it's available via the control plane. You can set it up. What we do not provide is advanced setup. So if you need advanced setup like FASync, or if you need observers, so automatic failover, that is not yet available in the automatic backup, in the automatic DataGuard, which we provide. The recommendation, if you need extended there, then it's best to set it up manually and not maybe to use the control plane for this. But in general, control plane does help you in easily creating an active data guard or a data guard, depending on the edition you have chosen. It does automatically protect you with asynchronous mode, so maximum performance mode within the AD and across AD. We are just implementing the way that you can change it also to max availability if you are within a region to different fault domains or different ADs. So a few best practices on DataGuard. I did cover the most things of that one already. So please use the Oracle notification service. So ASM-based instances, because that provides you with the fast application notification capabilities. Use as a vCTL to create your own services. That is really a must, because unlike autonomous, we don't predefine them for you. And there's a few things also to note. We implemented DB block checking in full on the DB system. That is important to know, because most customers doesn't use this on premise. And I've seen a few cases where switching that back to typical, like we have it on LVM, is probably a little bit better for your performance if you need a little bit performance tuning. So if you do all that, it's easy to essentially get your MAA even for VMDB system up to a gold level. If you need to go one level further, like platinum, then you also want to configure Golden Gate. So it is achievable, but not 100% out of the box, because things like Active Data Guard or FastSync, as I said before, have to be configured manually additionally. So while talking about ADs and fault domains, just a quick recap, which I'm sure you already know, but just to ensure that this is not forgotten, the normal architecture nowadays with the new regions coming in OCI is single AD regions, and within the region to essentially provide some kind of protection, we do have the fault domains. And as I said before, real application cluster instances are started in always separate fault domains. You can define them when you actually create a real application cluster where you want to have your nodes running. The regions and the fault domains are ensured to have isolated power and network. There are 4 regions which are a little bit more advanced, which are our triple AD regions, Ashburn, Phoenix, Frankfurt, and London, which also do provide the way to set up data guard between the ADs, which are a few kilometers apart, which provides a very good MAA perspective. However, as the decision has done to launch more regions than a few regions with triple ADs, the decision was done to launch more single AD regions. So unfortunately, that triple AD, which is very good for the MAA architecture, is not available in all OCI. So coming a little bit to scalability. So how essentially is scaling handled within OCI? And for knowing scaling, you should also know a little bit about how real application cluster is implemented in OCI, because scaling does use a few things of real application cluster. And one thing, actually, I have to jump over this. So I can explain you how real application cluster is implemented. The reason I had it in here was essentially the capability that real application cluster does provide the capabilities to provide you with online scaling for VMDB systems, essentially without downtime. I also did put in the slide here because I wanted to show you that within a VCN, you get the full control of a real application cluster if you're running on DBCS or XCS. So even things like adding additional IP addresses from a high availability perspective. So if you want to make your applications highly available, you simply can add IP addresses to your cluster that is fully supported. The only thing which is not documented clearly is that on the VCN level, you also have to add a floating IP address that you get the same construct in the VCN level to provide this high availability for you. And this is the reason why I put it in. Now, talking about scalability, what I actually wanted to get to is VMDBCS does provide scaling, which is a change shape. Now, a change shape does have more effect than just scaling OCPU. Change shape does change, yes, it just changes the OCPU, but it also changes memory, it changes network. We do ensure that when you scale, we do change the huge page settings within the VM so that your database will automatically also have more memory assigned and use it correctly, because huge pages is quite important for larger instances. And we will also make sure on scale down, we do scale this down. Unfortunately, that's change shape because it does not only affect your OCPUs, and because of the other thing I mentioned with the no noisy neighbors in OCI. So where we do ensure that no one is ever running on the same OCPUs as you do, that also has the drawback that you cannot necessarily scale online, because scaling online with a VM would essentially mean that you simply add more CPUs to the VM. That is possible as long as your host, your hypervisor you are running on, is not fully saturated. As soon as it's fully saturated, what essentially needs to happen is to move you to another host. And that cannot be done online as easy, especially not with especially not when you also have to change memory. and to change the network. So while we do see some advancement in the online scaling capabilities on the flex shapes, which are not yet supported via VM DBCS, so I do expect to see a change there once the new Intel shapes in OCI come out and are supported by DBCS. As of today, the only way to scale online is to use real application cluster, because then the scaling will essentially happen rolling. So one node after the other, providing you with the capability to scale online. And yes, a single node scaling takes about 10, 15 to 20 minutes because of that. If you do need an online scaling capability, then the recommendation is essentially to use XSCS, because XSCS provides this without any downtime, because on an XSCS, you always have access to all the CPUs, to all the memory and all the storage you essentially have, because it's a dedicated shape for you. And then scaling the CPUs is not growing into someone else's area, because it's your server, no one else is on there, and you're just telling us you want to use more CPUs, and you have to pay more for it. But therefore, scaling on XSCS is easily be done online. There are a few things you should essentially remember, that if you scale up and you run multiple databases, you might also want to ensure that the CPU count is for the individual databases you are running on XSCS is also increased after. So things like which are automatically done on VM DBCS, because we only have a single database, you have to think about how to do this on XSCS. Adding storage and compute nodes, by the way, is available with the newest Exadata shape X8M. So there you can even add a storage or compute nodes. This is also online, but it's not like instantaneous. Adding a compute node still takes a few hours to essentially ensure all the cluster stack and all your databases are extended to the new compute node when you add it. Autonomous. On scaling side is even better. There we already have implemented auto scaling and online scaling for sure, because it's running on an XSCS. The auto scaling capabilities for autonomous allow you to automatically scale to 3 OCPUs whenever needed. Now for the customers asking, can't I have something like auto scaling also on DBCS or on autonomous? Yes, there is a way. There are 2 ways to this, and the one node describes how to essentially set up OCI CLI on a DBCS node to essentially automatically allow to use OCI CLI to execute the scaling. And the second node is essentially a node how to do auto scaling on XSCS and XSCC and also DBCS VMDB systems. Now, you don't want to scale a single instance systems, VM DBCS systems, as I said before, because that, takes a while. So looking at my time, I'm pretty close. I was 45, so we still have about 10 minutes. So let's look at what we do provide if you do want to set up hybrid cloud and hybrid data guard. And the easiest way essentially to get into the cloud is essentially to use the cloud just for backup. And but there are also other ways. So backup to the cloud is one thing you could do, but you also could decide to set up a hybrid data guard, run your database on premise and have the data guard running in the cloud on a smaller shape, and then essentially scale up. And depending on where you are coming from, there are a few choices or few capabilities where essentially to set up your standby in a hybrid cloud environment. You could decide to essentially just say, okay, single instance, which from an MAA perspective just provides you with a bronze level. If you want to go to a real application cluster option with data guard, then you're actually already on a gold level. Now for autonomous, if your target is not a DB system or a VM cluster where you get full control over like an XSCS or DBCS case, you essentially are assuming that, autonomous does make sense, because I can save a lot of work in maintaining these instances, because it's everything is done for me. Then the way to set up a hybrid model as of today would be to use Golden Gate or the OCI Golden Gate service. So let's start with a simple thing, backup and restore. How does backup and restore work? So backup and restore to the Oracle Cloud would essentially be using the cloud backup module. The cloud backup module is a small module which can be downloaded to your on-premise system. It's the same module, by the way, which is used on DBCS instances and XSCS instances, so there's no different there. With a cloud backup module, you also get automatically the capabilities to encrypt your backup and to specify compression. So that comes with the backup cloud module. And it also automatically takes care of the configuration and of the upgrade to send backups to the object storage in the cloud where it's essentially ensured. And that can easily be used with your object storage to send your backups to. A few things with the cloud backup module you should know. It's best practice, so be careful. There are two ways to configure the cloud backup module. One is the old way, using a Swift endpoint. So you essentially could also use the cloud backup module to essentially access any Swift endpoint. But in OCI, you definitely want to use the native API endpoint, because that provides you with a little bit more advanced capabilities, like also using archive storage as your destination point. The target for this, if you configure it yourself, unlike DBCS, where this is all managed for you, in case of backing up an on-premise database instance, we will be using your bucket you specify, so it will be in your tenancy. The cost is a little bit higher than just object storage, because we will be charging for the cloud backup module. The reason is you even get compression without the advanced compression option for your backup, and you also get encryption without having to have the advanced encryption option, which normally is required if you want to use these two things. Important to know that for backing up to the Oracle Cloud, you really should try to use as many channels as you can. It's definitely also a good idea to maybe have a fast connect to send your backups over. There's another way you can use for backup. If you are interested in restoring the database, then later in OCI, there's also a small Perl script, which is also using the backup module, but which essentially does back up your database to an internal bucket in that case. But that then provides you with some capability in the UI where you essentially can click on a button and say, oh, from that backup, I do want to restore a database in OCI. This is there for having the backup in OCI and the capabilities to start a DBCS instance. It's not necessarily the way you would be migrating databases to cloud. There's a better tool for this, which is called zero downtime migration, which I have on the next slide. Important for the backup performance, I covered this already briefly when I discussed this in case of a VMDB system, and it's actually also true for backups from on-premise to the cloud. So you do want to have multiple channels. We essentially in OCI did find that you need about, and you can see this on the graph here, about 15, so about 12 to 14 channels is really an optimal way to get really good performance for your backup on OCI itself or to OCI. I mean, you still have to figure this a little bit out from your on-premise backups. There's a good MAA white paper how to assess this and how to find out what is the best way to parallelize and essentially send your backups to the cloud with the optimal speed. Though always keep in mind, the OCPU also defines on how much parallelism you can have. And if you just have a standard edition, then yeah, you only get a single channel. So it doesn't matter if you use more. So second case for hybrid data guard. So in hybrid data guard, first off, I have to know that where I'm coming from. So potentially your on-premise database can be on Linux or Windows. There's good MyOracle support node, data guard for heterogeneous primary and physical standby, which is maybe known to some of the on-premise customers. You can also, this is the same source essentially for defining if your standby database should be running in cloud. There is a few versions restrictions here. Which essentially have to do that in OCI. We do want that the customer stay in actual. So we do provide capabilities to patch your system, but on the same time, This also requires you to be on one of the latest release updates. So we have this thing N-3, we call it, so that you can launch with the most actual release update or with one before that. It can be newer, so that is not the issue here. And by the way, if you need to have special one-off patches, there is actually a really nice feature in OCI for the VMDB services, which is not available for IaaS, which is called custom database image. So custom database image lets you exactly define what additional one-off patches you want to have in your database you are deploying in OCI, and we essentially are creating a DB home for your DB systems, which is also used when you set up data guard environment and these kind of things. So that's a really cool feature. And we do have quite a few XSCS customers which are really happy about that they don't have to install patches with one-off patches anymore and using OPatch, but essentially can just build a new custom DB image and use that for patching. Architecture, same as destination for sure for the on-premise. For DBCS and DBCS RAC, it should be a container database because that is the way these are created. On XSCS and XSCC, we also allow non-CDB to be your target. However, to be honest, I mean, if you set up a physical data guard, your standby database will be exactly what your primary database has been. So when you do set up a physical data guard, and if you have a non-CDBs, it stays a non-CDB. So addition, we do, depending on what you need, for data guard, you at least need an enterprise edition. For active data guard, essentially, you need to have active data guard option on premise. On the DBCS RAC side, you need then the Enterprise Extreme Performance Edition, which is included in XSCS and XSCC. Some things for setting up hybrid data guards, analyze your network. There's a small, really nice tool, which is called Aura TCP test. It's in this assessing tuning network performance to essentially know how to best set your buffer sizes to send data to the Oracle Cloud to make sure your hybrid data guard is working the best way. Yes, if you do have fast connect, that's definitely preferred. And one of the things you should keep in mind is, in the cloud, we do enforce for your own safety to encrypt your databases. And while this does not necessarily mean that the primary has to be encrypted, see that master node for transparent data encryption and the tablespace encryption behavior in Oracle Cloud, it does come with a few caveats to simply keep in mind when you don't have transparent data encryption, though in most cases you can work around this. So hybrid data guard implementation, high-level steps. Because of the time, I won't cover all steps which you should be doing. There's a good white paper to this, which I have linked in the addendum. And the other solution for setting up a hybrid data guard is essentially to use zero downtime migration, because zero downtime migration is not just there to migrate your databases to OCI. ZDM can also be used to essentially stop before and essentially stop at the time when you're saying, oh, this is sufficient. I have set up data guard. Now I don't want to swap roles. My primary is still running on my on-premise system. I stop there and just have data guard running. That can also be done via ZDM. So you don't have to do all these manual steps and all these things yourself manually. So a nice thing to do, and I really can recommend. Look at ZDM. It doesn't cost you anything except the VM machine to install the ZDM tooling on, so that's okay. So resources, lots of resources you can look at. The most important part is probably the MAA website. Go to www.oracle.com/go/MAA. There you will find everything. So this is just an extract for the most common things. I essentially did show like hybrid data guard to our cloud infrastructure from on-premise, which you can essentially find on this white paper here. and also a few other things about the backup cloud best practices and everything. So I actually wanted to cover questions during my presentation, but I do now see. So there is one question about the pricing to the backup cloud, the backup cloud service. Yes, the pricing itself is cheaper than the object storage, but it's an addendum. So you essentially will always have to pay for the object storage. That's always existing. And this is an additional charge which comes on top of it. So if you actually want to back up to the Oracle Cloud, you will be charged for object storage space plus the backup cloud service. It's not an or, it's an and, unfortunately. Yeah, I just answered this one. So. Okay, someone just mentioned that, yeah, he tried this and he was actually only charged for the object storage costs. And he was not charged for the backup cloud service. So some internals. If you configure the cloud backup module as it has been for OCI Classic to the Oracle Cloud, with a Swift endpoint without the advanced functionality to use archive storage and everything, then yes. If you configure it on the API endpoint, then essentially we will be charging. So that's a little bit connecting to the API. But as I said, with the API, you get the access to the archive storage, which is not available with the Swift endpoint. You get a few other access points here. So that's the reason why you really want to use the one with the API. But as soon as you use this, you will be charged for the backup cloud module. It has to do with the endpoint, essentially. Okay, thank you. And if there are no more questions, I essentially would give back to Kenna.
Awesome. Thank you so much, Sebastian. And thank you everyone for attending today. I do have one final, our usual poll that I'll launch while I do our thank yous. Oh, there it goes. All right. So if you would like to fill that out, that is also very helpful to us. And I do want to point out, I dropped a lot of links in the chat. If you want to save the chat, you can do that. Go up to where you would send a message. There's little 3 dots, and you can save that content so that you can go back and look at the replay or find the slide deck. And various things afterward if you want to find that out too. So thank you once again to Sebastian for this wonderful deep dive into new database features and technologies. And if anyone on the call has questions afterward, please feel free to go to the forum, continue the conversations, and we hope to see you next time. Thanks so much, everybody.